This is my first video lesson for Unit 5, the bonding unit. The bonding unit is a large unit, so I divided the bonding unit into 3 subunits, 5A, 5B, and 5C. We are going to start with 5A, which is about the ionic bond. So I want you to download the class packet for ionic bonding on my class website. Once you do that, go to page 2. We are going to discuss why do atoms bond in this video lesson. Learning target. At the end of the lesson, I will be able to explain how and why atoms bond. There will be a homework number 1, Junipod, which is based off this lesson. Now we're going to talk about a chemical bond. Here I have 2 atoms. Predict how these 2 atoms are going to form a bond. An analogy to a chemical bond will be a relationship. In order for there to be a relationship, there needs to be some attraction. So how are these 2 atoms attracted to each other? One way to think about it is to first identify the positive and negative parts of an atom. An atom has a positive nucleus and a negative electron. So a chemical bonding would be attraction between one atom's nucleus to another atom's electrons. And that attraction is a chemical bond. So for ionic, covalent, and metallic bonding, it's just variations of this attraction. So atoms rarely exist alone. The atoms that are monoatomic are the noble gases. So atoms will bond with other atoms to become stable. Learning check number 1. All chemical bonds result from what? Pause this video and resume once you have the answer. Okay, so there must be some attraction between the nucleus and the electrons. So the best answer is choice 4. Okay, so nuclei is just plural for nucleus. Do all electrons participate in bonding? The answer is no. Only the valence electrons participate in bonding. Valence electrons are the electrons in the outermost shell. For example, in neon, it has 8 valence electrons. Check of understanding number 1. Why do valence electrons participate in bonding but inner electrons don't? From the previous units, you should know that inner electrons are held more tightly by the nucleus than the valence electrons. In addition, valence electrons have more potential energy. Learning check number 2. How many valence electrons are in an atom of phosphorus? Pause this video and resume once you have the answer. Okay, so first you have to look up what symbol is phosphorus. Phosphorus is P, and P has 5 valence electrons. So that'll be choice 4. Remember, the last number in the electron configuration is the number of valence electrons. So now I want you to do this small practice. Figure out the valence electrons of each of these elements. Pause the video and resume once you've done it. Okay, so here's the answers. Hydrogen is 1, fluorine is 7, sulfur is 6, chlorine is 7, and argon is 8. Now we are going to talk about the role that energy plays during the bond forming and bond breaking step. Let's start with bond forming. Let's use this analogy. Let's say the atoms are like magnets. If you have 2 magnets and you put them close together, they automatically are attracted to each other. You do not need to put in any energy for them to come together. So same thing with forming bonds. You do not need to put in any energy for them to come together. So when you form a bond, you release energy. Another way to think about this is that atoms by themselves are highly reactive. They have a lot of potential energy, so they're going to keep bonding until they're stable. When something is stable, that is low potential energy. They're less likely to do something. So basically, before atoms bond, they have high potential energy. Then after they bond, they become stable, right? They have low potential energy. So basically, you're going from a high to a low energy state. So what happened to the energy? It was released after bonding. Now let's talk about the energy involved in breaking a bond. Let's use the same analogy with the magnets. So imagine 2 magnets are stuck together the same way 2 atoms are bonding. How are you going to break the attraction between those 2 magnets? You have to use some energy to pull those 2 magnets apart. So the same thing with the atoms. If 2 atoms are bonding, you have to absorb or use energy to break that bond. So just to review, a chemical bond is an attraction between atoms. So you need energy to pull them apart. think about the magnet analogy. So I know from your living environment or biology class last year, they sort of have these things in reverse. I want you to read the paragraph about the misconception about this on the bottom of page 2 in my class packet. Basically, chemistry and biology are referring to different things. Chemistry is literally referring to the energy involved in the bond breaking and bond forming, while biology is referring to a set of reactions in a system. So technically, chemistry is more accurate. Since it's very easy to mix up these two concepts, here's a catchphrase to help you memorize this. BARF, breaking absorbs, releases forms. It even rhymes, so this means that bond breaking absorbs energy and bond forming releases energy. In every chemical reaction or process, there's always a bond breaking and bond forming step, in which bond breaking requires energy and bond forming releases energy. This is the respiration reaction that you learned last year in biology, in which you learned that energy is released in this process. So what does this mean? So energy is still required to break the bonds in glucose and oxygen, but energy is released when you mix CO2 and water. It just so happens the energy released from making CO2 and water is greater than the energy required to break the bonds in glucose than oxygen. So then for the entire process, energy is released. Learning check number 3, which is true concerning the reaction. Pause this video and resume once you have the answer. Okay, so the reaction is showing bond forming. So remember BARF, breaking absorb, releases forms. Since you're forming, energy is being released. So choice 2. As a chemical bond forms between two hydrogen atoms, the potential energy of the atom does what? Pause the video and resume once you have the answer. Okay, so you should know that atoms are highly reactive, right, by themselves, and when they form a bond, they become more stable. So the potential energy should decrease. So choice 1. Now we are going to talk about two terms that you can see a lot in chemistry, endothermic and exothermic. Endothermic is the process that absorbs energy, and exothermic is the process that releases energy. Like a lot of terms in science, one term means this, and the other term means the opposite of that. So I'll show you some easy ways to help you memorize these two terms. Endo means inner or within. Think of endoscope. Exo means outside. Think of exoskeleton. One easy way to memorize this is that endo, think of enter. Energy is entering the system. Exo, think exit. Energy is exiting the system. So check of understanding number 2. Is bond breaking a endothermic or exothermic process? How about bond forming? Breaking absorb releases forms. Since bond breaking, you're absorbing energy that is endothermic. And bond forming, you're releasing energy, so that's exothermic. Here is a chemical reaction showing the bond breaking of hydrogen gas. So where would energy go in the chemical reaction? Would you put it on the reactant side or product side? Since bond breaking is an endothermic process, you're absorbing energy, therefore energy should be on the reactant side. So now we have the opposite case scenario. Here we're forming a bond to make hydrogen gas. Since forming is releasing energy, energy will be on the product side because this is the exothermic process. So here's some practice questions showing some chemical reactions. Where would energy go in the chemical reaction? Also state whether the reaction is endothermic or exothermic. Pause the video and resume once you have the answer. Okay, so here's the answers. Well, the first one is exothermic, the second one is also exothermic, the third one is endothermic, the fourth one is endothermic, and the last one is exothermic. Now we are going to do a simulation, so get 2 pencils and a rubber band. Once you've done it, resume this video. So a pencil represents an atom, and the rubber band represents a bond. So here are 2 pencils. I'm going to wrap it with a rubber band. This represents a molecule, in which the rubber band represents that single bond. So to break that single bond, what must be applied? So if you take those 2 pencils and you start stretching, right, eventually the rubber band will break. So you need to apply some energy in stretching that rubber band, pulling those pencils apart from each other. Now wrap the rubber band around the pencil again and stretch. So this represents a molecule with a double bond. Now wrap the rubber band around the pencil again and stretch. So this represents a molecule with a triple bond. Now, what do you notice? You may have noticed that it gets progressively harder to stretch and break that rubber band. In addition, the pencils are closer and closer to each other. So compare the distance between the single, double, and triple bond. From our simulation, you should notice that the triple bond has the shortest distance, while the single bond has the longest. As you stretch the rubber band, what do you notice about the strength of the single, double, or triple bond? You should have noticed that the triple bond was the hardest to stretch, then the double, then the single. So the triple bond is the strongest, then the double bond, and single bond is the weakest. What is the relationship between bond strength and distance? Notice is an inverse relationship. The stronger the bond, the shorter the distance, and vice versa. Now we're going to talk about bond energy. So bond energy is not on the regions, but I'm going to talk about it anyway. So bond energy is defined as the amount of energy required to break apart a mole of molecules into a component's atoms. It is basically a measure of the strength of a chemical bond. Here I have a table listing out different types of bonds and their bond energy. Remember, breaking a bond requires energy, so the more energy you need to break a bond, the stronger it is. Learning check number 5. Which bond has the shortest average bond length? Pause the video and resume once you have the answer. So the relationship between bond length and bond strength is inverse, so the stronger the bond, the shorter the length. So bond energy is the measure of the bond strength. So the greater the bond energy, the stronger the bond. So CO is the strongest bond over here, therefore it will have the shortest bond length. So the answer is choice 2. Another way to think about it is that CO has a double bond, while the other types have only single bonds. Which bond is least stable? Pause the video and resume once you have the answer. In the context of chemical bonding, a bond that's least stable will be the easiest to break. So based off the bond energy, which one is the lowest? That'll be the CC single bond. So the answer is choice 3. That'll be the easiest to break, therefore the least stable. Learning check number 7. Which bond is most stable? Pause the video and resume once you have the answer. So here is asking about the opposite case scenario. So the most stable will be hardest to break. So looking at the bond energy, notice that CO double bond has the highest bond energy. Therefore, it's the hardest to break and is the most stable. So the answer is choice 2. So this concludes the video lesson for today. Remember to do the Junipod homework.